Welcome to our next video on section 6.5 of the Red Book, Adding and Subtracting Fractions. As you may recall, when we are adding fractions, we need a common denominator. So the first thing we're going to recognize is that fractions can be separated by the common denominator, or we can actually combine them, as you will see here. A over C plus B over C equals A plus B over the common denominator of C. The same rule applies for subtraction, so that as long as we have the common denominator, we can combine the numerators using the subtraction and leave it over the common denominator. If we have a common denominator already, that's a simple question. We're just going to add the numerators, 5x plus x, get our sum for the numerator, leave the denominator as it is as a 12, but then notice we need to look to simplify. 6 and 12 have common factors, so we can definitely reduce, and what our final answer is going to be is x over 2. We have another example where we already have the common denominator, but this one uses subtraction, which is of course harder because we have to be careful with our signs. We are not just subtracting the first term in the second fraction. We are subtracting the entire second fraction, which means that when we do our work, I like to use parentheses. We have 8x plus 10 minus the quantity of 2x plus 1. That negative, in other words, needs to be distributed to each of those terms. So we're going to have 8x plus 10 minus 2x minus 1. And when we combine our like terms, then we can put it over the common denominator. So here, we're going to have 8x minus 2x, which is 6x, and 10 minus 1, which is 9, all over the common denominator. But yet again, we are not finished because we want to look to see after we've added or subtracted if we can factor and then simplify. Here in the 6x plus 9, we have a common factor of 3. If we take that out, then we can go ahead and reduce because 3 and 9 have common factors. Our final answer in this case will be 2x plus 3 over the denominator of 3. So again, remember that you're subtracting the entire fraction. Once you've finished with simplifying the numerator through addition and subtraction, look to factor again to see if you can reduce. So this is our first example where we don't have a common denominator. What we want to do is find the LCD that we learned about in the last video. Because there are no common factors, we will use the LCD of the quantity of x plus 2 times the quantity of x plus 3. That means that we're going to transform the first fraction by multiplying by what it's missing. In this case, it's missing the x plus 3. And then we're going to look at the second fraction, and we're going to say, well, gee, what is it missing to get to the LCD? It's missing the x plus 2. So we'll multiply both the numerator and the denominator by what's missing. That will lead us to, again, distribute here. And I'm going to, as a shortcut, sometimes write LCD for the quantity of x plus 2 times the quantity of x plus 3. And here, because it's a 1, I don't have to distribute, so that makes it easier. Once I distribute the 2 to the x plus 3, I get 2x plus 6 plus the x plus 2 all over the common denominator. So now I'm going to be combining like terms, 2x plus x and 6 plus 2, and that will lead me to 3x plus 8, and now I'm going to go back and use the LCD that we defined, the quantity of x plus 2 times the quantity of x plus 3. So even though I use that shortcut in my work, at the end we never want to leave it as LCD because our final step is to check to see if we can factor and cancel anything else. Well, 3x plus 8 is prime, therefore there's nothing else that we can do. So in our next example, we have what looks to be almost the same denominator, but not quite. Now, we can make this a really hard problem by making our LCD x minus 2 times the quantity of 2 minus x, or we can change the way this looks and we can factor out a negative from the 2 minus x. When we do that, we can then change this sign by moving this negative up. So again, make sure you're understanding what I just did. I factored out a negative from the second fraction, took that negative, and now I'm going to change the plus to a minus because I factored out the negative. So I have 3 over x minus 2 minus 5 over x minus 2. That allows me to then say, oh, 3 minus 5 all over the common denominator, and that gives me a negative 2 over the common denominator. This problem becomes very complicated if you make the LCD x minus 2 times the quantity of 2 minus x. It will come out correctly, but you'll do a lot more work. Our next example has monomial denominators, and we want to recall that our LCD can actually be one of the denominators. So in this case, 6m would be our LCD, and that means all we're going to have to do is multiply the first fraction by what it's missing, which is a 3. That will give us 15 over the LCD of 6m minus 1 over the LCD of 6m, and that results in 14 over the common denominator of 6m. Recall again that we want to always look to reduce, and because we have common factors in 14 and 6, we're going to take out a 2 in both, and so our final answer will be 7 over 3m. Okay, so now we're going to look at another one that has a numerical denominator. And so our LCD here, thinking about the least common multiple between 6 and 10, would be 30. So if we have an LCD of 30, then what we're going to do is we're going to think about what are we missing in each of those fractions. So I'm going to just rewrite the first fraction, a over 6. To get to 30, we would need to multiply by 5. Well, we can't just multiply the denominator. We have to multiply the numerator and the denominator. And the second fraction, in order to get to 30, we would need to multiply the 10 by a 3. We can't just multiply the denominator, so we also need to keep it equivalent and multiply the numerator by the same number. That's going to give us 5a over the LCD minus, now again, we're distributing here the 3, so that's going to give us 12 plus 9a over the common denominator. So recall that this subtraction means that we're subtracting every term in the second fraction. So I like to use parentheses, or if you can just remember to distribute the negative, but that means that I'm going to end up with 5a minus 12 minus 9a over the common denominator. And now I'm going to combine my like terms. 5a minus 9a is negative 4a minus 12 over 30. So recall that we want to look to see if we can factor. So I am definitely going to factor out a negative 4 here. And that leaves me with a common factor of 2. So I am going to reduce here. And my final answer then, again, you can leave the negative with the 2, or you could put it in front of the fraction bar, as I'm going to do. And you can leave this in factored form as 2 times the quantity of a plus 3. So if we scroll to our next example, we again have another monomial example. And our LCD here is going to be 6a squared b squared. So we're going to think about what's missing from each fraction. So I'm just going to, again, rewrite, leaving room to in front of each of these. So our first fraction is missing a b squared. Our second fraction is missing a 2 and an a squared. Our third fraction is missing a 6, an a, and a b. So now we can create equivalent fractions with the common denominator. So that's going to give us b squared over the LCD plus 2a squared over the LCD minus 12ab over the LCD. So we're going to be careful here, and we're going to write this in a form that might enable us to factor 2a squared minus 12ab plus b squared all over the common denominator, 6a squared b squared. So if I tried to get the factor pairs of 2 and the factor pairs of 1 to add to negative 12, I'm afraid I'm not going to get anywhere. So that trinomial is prime, but you would want to consider whether you could look for a GCF or something which might help you reduce this. In this case, we are done. So our last example, I have this example, and then I actually added one on just to give you one that's a little bit more challenging. In this case, we have a y plus 1 and a y. Now, even though they both have a y, recall that in factored form, these are two different entities. So our LCD is going to be y times the quantity of y plus 1 because they don't share any common factors. So again, I'm going to just say the first fraction we're going to multiply by what's missing on the numerator and the denominator, which is the y. The second fraction is missing the y plus 1, so we're going to multiply the numerator and the denominator by what's missing. And that will give us 2y over the LCD plus 5 times the quantity of y plus 1 over the LCD. So when I distribute, I get 5y plus 5, and again, our LCD is y times the quantity of y plus 1. We're going to add our like terms, and then we look to see if we can do anything else, but in this case there are no common factors. All right, I added one question to the bottom just because I wanted you to see one where the factoring was a little bit more involved. So what I'm going to do is I'm going to factor the denominator here to x plus 2 and x minus 1. And then I'm going to factor the denominator here to x minus 2 and x minus 1. It's the same process, but this is just a little bit of a more challenging question that we'll have questions similar to this. So what I'm going to do then is make the LCD. I see that I have a common factor of x minus 1. Remember, I only use that once because both of the fractions include that. X plus 2, though, I need to include, and I need to include x minus 2. All of the factors, the most time they occur in any one of the fractions. So what I'm going to do then is I'm going to multiply each fraction by what it's missing. So the first fraction is missing the We have an x plus 2 and an x minus 1, so it's missing the x minus 2. So I'm going to multiply by x minus 2 over x minus 2. And the second fraction has an x minus 2 and an x minus 1, so it's missing the x plus 2. So that gives us the common denominator that we need. In the numerator, we have x minus 2 quantity squared. So I'm going to go ahead and multiply that out rather than writing it x minus 2 times x minus 2. We know that that's going to be x squared minus 4x plus 4 over the LCD. And here we have x plus 2 quantity squared, which is going to be x squared plus 4x plus 4 over the LCD. Now recall that this negative is going to get distributed. However, it's easiest for you to remember, right? We're going to distribute that negative now. I'm not going to do the parentheses this time. I'm just going to make sure that I distribute to get negative x squared minus 4x minus 4. And that's all over the LCD. So now I'm going to have a lot of things that cancel. X squared minus x squared, those are opposites. I'm going to have negative 4x and negative 4x. Those don't cancel. That's going to give me a negative 8x. And then I'm going to have a positive 4 and a negative 4. And those are going to cancel. So what I'm left with is negative 8x over the LCD, which I will now write out as x plus 2 times the quantity of x minus 2 times the quantity of x minus 1. So we look, of course, we don't have an x factored out or an 8 or anything like that, so we are finished. That's as far as we can go. So that concludes this video, and we will be working on homework problems then related to adding and subtracting rational expressions.